In this video, we're going to take a look at performing multiple transformations to the graph of a function. So let's say we have our parent function as the square root of x again, and this time we're going to have all these transformations done to it. So we have a minus out in front, we have a minus in front of our x, so we're multiplying our inputs by a -1, we're adding 1 inside the square root, and we're subtracting 5 outside the square root. Well, if we look at the final product here, the final result of g of x, here's what we have. So there's a lot going on here. So let's break this down piece by piece. So first up, there we go. First up, we have this +1 inside of our square root. So if it's a +1, that's actually moving it to the left 1 unit. So let's build this graph up from scratch. So hopefully it'll let me do g of x again. Awesome. So we have the square root of x. We start with the square root of x. But if we add 1, that is going to be a shift to the left 1 unit. And then from there, we have the negative in front of the x. That's a reflection across the y-axis. So what actually happens is this graph in black, we're going to, just by putting the negative in front of the x, it's going to flip it, the entire graph, across the y-axis. So let me zoom in here so it's a little easier to see. Here we have before the reflection, and now all these points are going to get reflected over this y-axis simply by adding a negative sign to in front of the x. So from there we have the minus that's outside. That, of course, is a reflection across the x-axis. And we can build this up again. So now we can see the graph in black will get flipped over the x-axis by entering in the minus sign. And then we have the -5 afterwards is a shift down 5 units. So we're going to take this graph in black and shift. Now there is an alternate way of coming up with the same graph, but through a different means of transformations, and it involves factoring out whatever's in front of the x inside of our function. So if we factor out the negative inside the function, we get the square root of negative and then x minus 1 in parentheses inside the function. So the -1, or first up, the minus that's out in front is going to be a reflection across the y-axis. Then we have the -1 inside is a shift to the right. The minus that's out in front of the square root is our reflection across the x-axis. And then the 5 that's we're subtracting outside the function is shifting it down 5 units. And just so there's really no confusion as to, well, I did it this way, someone else did it that way, you may both be correct. To provide some sort of consistency and a little bit of standardized approaches here, we're going to look at our preferred order for transformations. So first, any horizontal shifts that we happen to deal with. So like the +1 moved it to the left 1 space. Then any kind of horizontal stretches or compressions and or reflections across the y-axis. So we saw what happens when we multiply our input value, our x value, by a negative or a positive number not equal to 1. We also have vertical stretches and compressions and or reflections across the x-axis. So that's all done outside the function. So these first 2 items are done inside, and then the next 2 items, the vertical stretches, compressions, and reflections over the x-axis, and the vertical shifts, these 2 are done outside the function. So we'll work from within the function, followed by from outside the function. So horizontal shifts, then any horizontal stretches, compressions, or reflections across the y-axis, any vertical stretches or compressions and or reflections across the x-axis, and finally vertical shifts. All right, so our parent function again is the square root of x, and we have 1 minus the square root of x plus 3 all over 2. So let's see what that looks like. Hopefully I can remember this. 1 minus the square root of x plus 3 all over 2. All right, so quite a bit going on here. We have some shifting, a little bit of reflection as well. So let's take a look. Well, first up, we have, we can rewrite this as negative square root of x plus 3 and all over 2 and then plus 1. Or we can break it up with fractions. Negative square root of x over 2 is 1/2 x, plus 3 over 2 is plus 3/2, and then plus 1. Well, we're going to shift it to the left 3/2 of a unit. So the plus 3/2 inside is a shift to the left 3/2 of a unit. The 1/2 that we're multiplying our x by is a horizontal stretch because we're multiplying x by a number between 0 and 1. It's a horizontal stretch by the reciprocal of 1/2, which in this case is 2. So it's a horizontal stretch by a factor of 2. The negative that's out in front of the square root is our reflection across the x-axis, and the plus 1 that's outside of the square root is shifting our graph up 1 unit. All right, so example 7, given the parent function f of x is equal to x squared, write the child function g of x after the following sequence of transformations. So let's start by shifting our graph up 2 units. So shifting our graph up 2 units means we're just going to add 2 to our function, and that gives us x squared plus 2. Next up, reflect across the x-axis. Well, if we're reflecting across the x-axis, then we're just going to multiply our entire function. So not just the x, but the entire function by a negative. So if we want to, we can distribute the negative through. We get negative x squared minus 2. So if we're multiplying the whole function by a negative, we might have to put in parentheses and use the distributive property. Next up, we're going to shift this graph to the right 1 unit. Well, shifting it to the right 1 unit, we need to, for any kind of exponents, any kind of horizontal shifting, we need to use parentheses for. So inside the function, we need to do a minus 1 for shifting it to the right 1 unit. So we have negative parenthesis x minus 1 parenthesis squared minus 2. And a horizontal stretch by a factor of 2. We saw this in the last example. We're just going to multiply our input by 1/2. So we have negative in parentheses, the expression 1/2 x minus 1 all being squared, and then followed by a minus 2. So just building the function now based on the steps that we had to take. So, all right, that about does it for this.